Let's see what we can do here with number 7. So in 7, we want to evaluate this function when the input value is 5x plus 4. So we'll set these up like we typically do. We'll write we'll write an open set of parentheses for that x. Everywhere we see an x, right, we write open parentheses. There's an x, so open, and then plus 3. And then what we're going to do is we're going to put that 5x plus 4 into each one of these. Let's see what it looks like. So this will be f of, okay, we'll get, let's try that again. We'll put the 5x plus 4 there. We'll put a 5x plus 4 here. We'll put a 5x plus 4 here. And then we've got the plus 3. And now, this 5x plus 4, we know how to do that, right? That is going to be, talk our way through the pattern here. Square the first, 25x squared. Multiply these two together, 20x, but double it, 40x. And then square the last. Square 4, we'll get 16. Run that negative 6 through, so we'll get minus, oh, that's a 5x, minus 30x, minus 24, and then a plus 3. So let's see, where's this put us? 25x squared, and now this looks like a 40x minus a 30x gives us a 10x. And then, where are we? Then we've got 16, so if we can keep track of this, 16 minus 24 plus 3. So negative 8 plus 3 is negative 5. So we'll put on a negative 5 there. So we'll conclude now that f of 5x plus 4 is 25x squared plus 10x and minus 5. And now in number 8, I expanded this thing a little bit here. So in number 8, we want to find f of negative 4. So the input is negative 4. So remember, the horizontals are the input values. The verticals are the output values. So let's find the input of negative 4. So we'll come down to the x, 1, 2, 3, 4. There's negative 4. Follow it to the graph. Looks like it hits the graph right here. And then we can follow it over. Right, negative 4 comes up here. Follow it over here. Looks like a 1. So let's conclude now that f of negative 4 is a 1. Now, in problem number 9, we're supposed to find the input value that produces the output value of negative 3. Remember, that whole collection of symbols is an output. So it says the output is negative 3, and find the x that produces that output. So look at the graph here. Locate yourself on the output, the vertical axis at negative 3. So remember, the vertical axis is the outputs. So here we are at negative 3. I'll put a dot there, negative 3. And what x value produces that? We can see we don't go left or right. We're right there at 0. So we're going to conclude then that the output is negative 3 when x is 0. What we're looking for here in problem number 10 is the composition of these two functions. So let's just write down what this is supposed to be here. So this right here means this. This means f of g of x. Now let's just bring this down. This says f of g, but we know what g is, right? G of x is 2x plus 7. So we'll put in 2x plus 7. I'm going to do it over here on the left. So we'll have f of 2x plus 7. And then the question is, what do we do with this 2x plus 7? Well, this says that we apply the f rule to it, and here's f. So we know what to do here. Everywhere we see parentheses up here, we're going to write an open, everywhere we see an x, we're going to write an open set of parentheses. So we'll have f parentheses equals parentheses squared plus 6. And then in the parentheses, that's where we're going to put our 2x plus 7. So let's give that a try. So now we're going to have f of 2x plus 7. That's 2x plus 7 squared plus 6. And now we'll square this. We'll talk our way through the pattern. Square the first, 4x squared. Multiply these two together, 14x, and double it, plus 28x. Square the last, 49. Add that 6. So all in all, we're going to get 4x squared plus 28x, right? Multiply these together, you get 14x, and double it, you get 28x. And then the 49 and 6 is going to give us a 55. So let's conclude now that f of g of x is 4x squared plus 28x plus 55.